Alright, making a video. Another one. Yeah, another video. Will they ever end? Da, 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 da. So, anyway, this is all a story. The your life is a story. All these little events, a lot of sub stories, I guess you could say, whatever. Little tales that are all part of the whole story. And so but anyway, and there's going to be you know they lived happily ever after somewhere. There's going to be a conclusion, and this is probably more like a horror story, so everybody will be dead in some sort of horrible and grisly manner. So it's good. Yeah, it's not going to be a good story. But the little sub story, that is this physics argument. Um, yeah, there's going to be a resolution eventually. It's not like it's going to be forever caught in this quagmire of bullshit and statements that even though they've had 300 plus years to compile a little bit of evidence, they're just going to tell us this Jesus exists, and they don't feel any obligation to demonstrate it with anything reasonably called evidence. Credible evidence. Evidence that can't be debunked by, commoners even. Even a commoner, a regular person, can apply a little tiny bit of logic and point out how that don't work. Okay, you got the bicycle upside down. It doesn't work when it's upside down. Something that simple. So anyway, this moron, belligerently hostile, nasty, creepy, cruddy, shitty human being, Ian Gosling, has made another stupid, useless, pointless video. So we'll play it. Oh, it's just, it just goes on and on and on. Okay, that's viewable. So he's making a rationalization for the Stephen Bro was supposed to have this new video. He never showed us. He never did it. Whatever. I don't know. Who knows? He got too disinterested because he got rich or something. I don't know. Some sort of bullshit. But as with all his promises of all these videos he was going to make, he doesn't make. He just says he has the evidence and he never shows it. So, not never, but I mean, the videos that are supposed to be, decisive, never show up. The ones that are supposed to clarify and prove finally, they never show up. And we're just left with 4-second clips of crap. Stuff that has been debunked. Anyway. Alright, so I'll draw first. Because he starts talking about... So Stephen Bro did a semi-simple experiment. Okay. Lever. Fulcrum. Yes, well, he put the fulcrum in the right place. I think he had the whole lever, so if I'm not mistaken. Alright, he had a spring, and what he basically did was push on the spring, that is, create a compression, so the lever always went to the same location, and a little lock on it. Okay, so he put the same amount of energy in. He pushed against the spring, and now this end's going to swing back. Alright, so this is the energy in. Okay, energy in. Alright, and it's the same amount. And then he did a simple thing here. He put a 2 mass here, and you could say a 1 mass here. Alright, and did the experiment. Now, when he did them at the same time, obviously they had less velocity, but he didn't give us those numbers, so we don't know exactly what that velocity was. I guess I could move that over here without messing up things too much. But anyway, obviously when these two things leave and it's the same, they're both on the lever at the same time, then he got the exact pretty much numbers of this one's going 1/2 the speed, so it's 2 okay, times 1/2, and 1, not times 1/2, right? 1 times 1, okay, and so you end up with the 1 answer. So they both have the same energy, yeah, the same momentum. All right, so we're supposed to think that, somehow the rules change when you take one of them off. So anyway, so he does the experiment first with the 2 mass and calculates a velocity, and let's say the number was 19, okay, for the calculation of the velocity. And then he removes the 2, okay, and he puts the 1 over here, all right, going twice the speed. Now, who knows how perfectly he calculated distances here. It's, it's a Brozo experiment, so it's not done with precision, which, my argument is science experiments should be done precisely, okay? It's important to get it right because all these subtleties matter. All this seems like or looks like is very dangerous, so you have to be very careful to make sure you're actually getting to the truth, and they don't think so. So anyway, so he does this one and gets 11. Okay, so now the excuse they're using, see, that's pretty close to 2 to 1, right? It's pretty close to exactly what you would expect. Half the mass going twice the speed as the 2 mass. So pretty close to the right answer. Now, what there was, as you could see, this, he did this on glass. So it was a nice, flat, smooth surface, low friction anyway. And there wasn't any visible rotation in this object. So it shot up without rotating, okay, without any rotation. And this one, okay, the 2 mass, because it is going a little slower, okay, so funny, it's going slower, and somehow the speed had something to do with it. Somehow speed had something to do with how much friction there was, because, you need the friction to roll. You can't roll without friction. Somehow the faster thing had less friction. It's another scientific idea, that they claim friction's always the same. It doesn't matter how heavy you are. Yeah. It doesn't matter how fast you're going. So the faster, lighter thing has less friction. Anyway. Okay, and so the 2, the heavier mass, did actually rotate a little bit. You can see in the experiment it's a tiny amount of rotation. So it's not like it was spinning very fast. And you could argue that it stored very little energy. The energy of a cue ball, for example, billiard ball, the energy of its rotation is kind of minimal compared to its motional, that is, its directional linear velocity. So this is where like 90% of the energy is in the motion, and this much smaller percentage is in this internal idea that inside some of the matter is moving in more than one direction. That there's some motion stored in the rotation. So if I let it fly off a table rotating, yes, it'll do pretty much, the 2 to 1 thing, and the rotation will be a small percentage of any difference between the objects. But they say no, it's 50% almost, Well, they're saying this number should be 16 or whatever, right? 14. Yeah, 14. It should be slower. It should be going 14. And they're saying this difference in their answer is because of, all right, this rotation. So Stephen Bro claimed a month ago that he redid the experiment, did this much better way, and he got perfect results. Perfect. But he never posted the video. So he posted some other videos apparently that he thought were adding evidence, but he made private, and he never made them public. Yeah, so, yeah, whatever. So anyway, that's what he's claiming. So even though the experiment came out pretty much as you'd expect, 2 to 1, okay, the lighter object is given the momentum. It's the same momentum. It's half the weight, so therefore it compensates for half the weight by going twice as fast. It had every indication of demonstrating that simple truth that you conserve the momentum, that levers and springs conserve momentum. Now, regular physics probably says that. I mean, generally speaking, it does say that. I have overplayed Professor Lewin saying it over and over again. So this is conventional physics. Most physicists, I think, if you poll them and you ask them what this experiment will produce, I'm pretty certain they're going to say, yes, it's a 2-to-1 relationship. You have to conserve the momentum. But whatever. The problem is that doesn't, that indicates a conflict in their theories, because then their kinetic energy theory does obviously break down, because it's not going to be conserved, and it's not going to be conserved in the negative way, in the sense that the free energy way. They won't be able to use some simple jargon and say, well, when I add weight to a 5-ton train and make it into a 10-ton train, I lost half the energy through the mystical sparks and sounds and all kinds of crap that happened, when there's no evidence that any of that was half the energy. So, they really do think 2 10-ton trains going 5 miles an hour is only just equal to 1 5-ton train going 10 miles an hour. I need 2 10-ton trains on one side of the tug of war, 2 10-ton trains going 5 miles an hour to equal 1 5-ton train going 10. They really believe it. It's kind of funny. It's ludicrous. So that's what the story has in it. It has these ludicrous elements. So we have to fight through all these ludicrous elements. Because that's part of the fun of life on Earth with other fucking pieces of shit human beings.
Rolling this.
Okay, I have to probably do something with this volume, because this volume's always a little minimal.
Ball across this surface requires 2 types of energy. There's the linear.
So again, instead of explaining, countering my argument, so I made the argument over and over again that this friction he's describing, rolling something on a surface in gravity, gravity causing the friction, means that gravity is providing the pressure for the friction that's going to allow for any rotation in the first place, cause it, use some of the energy to rotate the object. And it's also going to pull the energy out of the object, but it's not going to do it evenly. So the faster it goes, the less it's going to consume. So instead of dealing with that argument in any way, doing any drawings explaining how I have misinformed anybody about how gravity works. 9.8 meters per second, by the way, per second. Obviously gravity comes in clumps that are time dependent. You have to wait for it. It doesn't matter how far you're going, it just matters how fast and how long you're in the gravity. So how long you're in gravity is what decides how free falling decides how much energy it can give you. And if you're not free falling, you're on a surface, how long you're in the gravity, how long the gravity is relevant, applying of counterforce to you while you're doing your moving, will decide how much force you lose to gravity, to friction. So, we've been over and over this. So, this force comes down at 9.8 meters per second. All right. So it's per second. It's a big giant S to emphasize it's a unit of time. So you can say in a unit of time you get a clump of this, 1 clump per second. A clump hits, and another clump of 9.8 hits, and another clump of 9.8 hits. It's per units of time that you are encumbered, by the force. I didn't get rid of that. I thought I did, but I didn't. Oh, that's the wrong one. This is the one I have to get rid of. Alright. 9.8 meters per second. And you're going to roll something across the surface then what's going to happen is it's all really going to depend on not the distance, but how long you're in the force. So if I give something twice the velocity, you can really understand that, okay, that means basically it's going to be in the force, it's going to go twice the distance for a unit of time. Twice the distance for a unit of time. That's what twice the velocity means, right? So one velocity is one distance per unit of time. Two velocity, twice the velocity, is 2 units of time. Okay, and so that's all that's going to really happen. So yes, this one will roll this far and no farther, 1/4, and this one will go 4 times. Okay, but in this last quarter is when it's going to be going 1/2 the speed. That is, it's going to be going the same speed this one started with, 1v. It's going to go 1v here, 1v. Okay, it started at 2v. Okay, it's going to go 1v here. All right, and it's going to go 0v here. Okay, and that's how it's actually going to happen. And the units here, this is going to be one clump of this time. Okay, this is one clump of time right here. And this is one clump of time. Okay, so this is a clump of time, this is a clump of time. The same force was applied here. So you could think of this experiment as if I did just put a bunch of scales across this surface with springs. So the whole surface, so I made the whole surface out of little springs, little scales measuring the weight. Okay, I'm saying it's an absolute definite fact that the faster I make it go across that bunch of scales, the less weight I'm going to read on each scale. So the faster I can get it to go, the less weight I'll read on each scale, because frankly it'll be in the gravity less time. It's just a fact. Per unit of added velocity. So the more velocity I add, the more this relationship takes place, and the less per unit of distance I'm losing my energy. So my gas mileage, you could argue, you could argue this is sort of just like gas mileage. Your gas mileage goes way up, okay, the faster you go. The faster you go, the more distance you get. Because obviously you're covering the distance much quicker and therefore evading, okay, these clumps of time. You have to hit fewer of them. So 4 times the distance, 2 units of time, okay, twice the velocity, and frankly, just twice the weight. So you can't change it. This is the way it does work, and what they talk is crap. They think this is 4 times the energy because it's 4 times the distance. Only 2 units of gravity, only 2 units of velocity, not 4, and only 2 units of weight, and weight is momentum. So it doesn't work. Their argument is garbage, and they just keep making it. And they no counter arguments. And that's the state of things. Oh, we have a comment. Let's see what it is. Should that be 9.8 meters per second every second? Doesn't matter. Then the part you're supposed to pay attention to is that it's in units of time. If it was in units of feet, it would be 9.8 meters per meter. Okay, if it was in units of weight, it would be 9.8 meters per pound. Okay, it's in per second. It doesn't matter whether you say per second, per second, per second, per second, per second. You can say per second 68, 78, 188 times. It doesn't matter how many times you say it. You're not going to change its 9.8 meters per a unit of time. Okay, it's not 9.8 meters squared anyway. I mean, that's just too stupid. So saying per second and squaring the seconds is just illogical shenanigans. I mean, that's such a simple little verbiage trick. I'm going to change per second into squared seconds. I mean, the fact that it can happen 7 seconds or 15 seconds or to 179 seconds means I square the seconds. Obviously, it's per second per second. Everything that's written as a rate, 9.8 meters per something, anything that's a rate can be a rate any number of times. It's just you're just saying how often did the thing happen. So it doesn't matter per second. You want me to say per second, even though I think it's absolute? You want me to say praise Jesus before I say anything? Like everything I say, I have to say praise Jesus first. I'm obviously not going to say per second because I think it's illogical baby talk. But yeah, if you want to believe that's what it is, fine. It doesn't change anything. It doesn't change that the units of gravity are coming per second. Fuckhead. That they're clumps of gravity and they come in a unit of time. 1 millisecond, 1/2 a second. It doesn't matter whether I make this, subdivisions. The same rule applies. You just put a decimal point. You just change where the decimal point is based on how you change the second. So I can say I can say 0.00098 meters per millisecond. I can say that. It's perfectly valid and it's perfectly true. Oh. People really just not up to the conversation. All right. I made a comment on Ian Gosling's latest video and Mindless Marble started attacking me out of nowhere. Well, geez, surprise. They're obviously club members. Okay, this is some sort of gang war. So anybody who chooses a side is, you gotta, you're stuck with that, buddy. You think units don't matter. What the fuck? So, I mean, is there a point where I should just block you? I mean, what the fuck? What am I saying units don't matter? I'm emphasizing it's per fucking second, you fucking idiot! How am I denying units? It's like, again, this is just nonsense. This isn't a rational response to what I'm saying. How the fuck did I deny the units? Alright, MS is the same as MSS. It's a time unit, you fuck! It comes in units of time! How are you not following along? If I fall 2 seconds in gravity, I'm not going 9.8 meters per second, in the sense that I'm not going 9.8 meters squared. So if you're going to write per second as seconds squared, I'm obviously not going 9.8 meters per second squared in the sense that I'm not going 9.8 meters squared. Okay? So we know that's not the right answer. What is the right answer? Oh, that's right. It's 2. Okay, if I drop 2 seconds in gravity, 2 times 9.8. Isn't that the right answer, fuckhead? 2 units of time, okay, times 9.8. And that'll actually give me the right answer that I will be going 19.6. That's the correct answer, fuckhead. It's an absolutely correct answer, and you're sitting here talking this gibberish saying I'm somehow making a mistake. You don't believe in units? You don't believe in physics? You don't believe in science? Fuck you in the ass till fucking dead. You have no right to say that, you shit. Especially when I have a big giant ass on the fucking goddamn board. I have little T units all over the fucking goddamn place. I'm talking about units. I have them in things, brackets, showing that they're units. And you're saying I'm denying units? Fuck you. Alright. I don't mind what you say. I don't fucking give a damn what you mind or don't mind, you rude fuck. But if you say the acceleration due to gravity is 9.8 meters per second, it makes it sound actually logical, because it's a fucking rate, and that's all it is. Your velocity is a rate, 60 miles an hour. Your acceleration is a rate that happens per hour or per second or per day. Okay, it's just a fucking rate, jackass. There's no logic to you saying velocity isn't per second, but acceleration is. There's no logic defending it. There's no reasoning defending it. It's absolute mathematical crap. It's a silly excuse to put a square where it doesn't belong. You're a stupid, ignorant dupe, okay? And you're talking absolute shit. And I have thoroughly debunked it. Your accusation that I'm misunderstanding what a unit is bullshit. You're misunderstanding. It's 1 unit. 1 unit. 1 unit. Numerous times. 1 unit numerous times is not units squared. Fuckhead. Okay. Makes you sound like you have a fundamental misunderstanding. Fuck you. Alright. You said it doesn't matter whether you say per second. That's right. I just said it. Now say it again and again and again. If you assholes think it's appropriate to multiply 9.8 times 9.8 times 9.8 times 9.8 to make your magical Jesus energy, that's not my bad. That's your preposterously silly theory. It's 9.8 times how many seconds? You don't understand that? And how does seconds squared say 9.8 times how many seconds? How in any fucking rational way does you saying seconds squared equate to 9.8 times the number of times you're in the 9.8? Of course it doesn't. Multiplying 9.8 times itself does not give you the right answer, you dumb fuck. All right. It's the same thing. That makes it units. Doesn't matter. Fuck you. Okay, I will just block you. You are going at 9.8, but you are accelerating. This is more baby talk. It's a rate of acceleration, you shithead. How does it make any sense to square 9.8? Just explain that. Would you explain how does it make any sense to square 9.8? Speed and acceleration are different concepts. Fuck you. It's baby talk. It doesn't mean anything. You say so. Oh, just because you say so? There's no logic for me to think they're different concepts in any way. One of them's a changing speed, one of them isn't. So what? It's all the same units. It's just like, it's again, like Newton says, you want to go twice as fast? Just add twice the force. There's no complication here. The complication is your problem. It's not in anybody's reasoning. You mad bro. Okay, well that's the end for you. Goodbye. Fuck off. I don't do the bro thing. I'm not your boy. You're the fucking idiot and you demonstrated you're a fucking idiot. You think it's 9.8 meters squared. Okay, then you're too fucking stupid for the conversation. If you think I'm supposed to square the 9.8, you're really fucking dumb, because then I'm going to get the same answer no matter what the fucking circumstance is. Because you don't understand their units of energy that gravity applies over time. Okay? 1 unit per unit of time. Not squared units. Alright, anyway. That was unpleasant. Okay, so moving on. Oh, God, I hate these people. Hate this planet.
Kinetic energy. And then there's rotational kinetic energy. Stephen Bro's experiment failed to show the one.
So it was on glass. So let's understand the rotation was probably just minimal. You know, like somehow something spins its wheels and it's not really going. The spin rate isn't the same as the rate. So it's like the inverse of the dragster whose wheels are spinning but the car isn't moving. The inverse effect takes place where, because there's so little friction, there's just a tiny amount of now and then adhesion and a tiny bit of rotation. So the rotation is much slower than what it would be if there was glue on the glass.
0.4, because the half mass skidded along the surface with very low friction force.
So again, this idea that skidding means there wasn't any friction. No, it means it was going faster. But anyway, it's okay. I'll play along. It doesn't mean that there's no friction. But anyway, I mean, that's only something you call a half-truth. Okay, because the bigger truth is that there's not enough friction to cause rotation, and that's all that statement should be.
So it went faster than it should have done.
So by saying it went faster, okay, he's just saying it should have been slowed down by creating some angular momentum like the other object. And he's claiming that the angular momentum is a huge amount of energy, when no, it's a small amount trapped in angular spin. Most of the energy is in its motion, 90%.
The best way to get...
So this is just horseshit rationalization for a bad experiment that Brozo was supposed to prove with his new experiment. Now, for the record, I predicted his new experiment would just be a rig, a jig, shenanigans. Okay, so he would just figure out some way to break, which was a perfectly reasonable experiment, and find some way to break it so it didn't work. But we haven't seen it, so we can't test that theory.
Get around this problem is to do away with rolling things on surfaces, and is by launching them.
Yeah, no, we could use a pendulum. Okay, so let's just use a pendulum. What's the difference, right? So we'll use a pendulum, and then we don't have to worry about rotation or any of that horse shit. So what's the problem? Yeah, okay. It's good enough for me.
From a spring into gravity, then you do away with the friction, and then you also do away with the rotational kinetic energy. Because I did that experiment.
Let's understand, he didn't do shit. Okay, so he did an experiment, and then I pointed out all these defects, and he just didn't care, and to respond to any of them. And so we'll point out what he did, and I'm just saying it's totally inconsistent with every physicist's claim that you have to conserve momentum. So he's saying that all of these objects, levers and springs and hydraulic vessels, all kinds of whatever I can create as a mechanism, none of them conserve momentum. That's his accusation. So why does physics say you have to conserve the momentum in these closed systems? Because he doesn't believe you do. Okay, so that's the simple truth. He doesn't believe in conservation of momentum. He believes in conservation of kinetic energy. So he says exactly the opposite of what Professor Lewin said. So he says nature can, nature can finagle momentum, but nature can't finagle kinetic energy. So he has exactly the opposite theory. All right, so he did an experiment where he's just going to launch things up, okay, with a spring force and use gravity to show us how much energy it took. Now, logically, we know that, okay, gravity does have this little bit of an illusion to it in the sense that if you double the velocity, you get 4 times the distance, okay, because of the fact that this is only 2 units of time. Okay, it's only 2 units of time. That means it's only 2 balls of gravity hitting you, okay, not 4. All right, this one got hit with 1 ball of gravity, 1 unit of time. This one got hit with 2 balls of gravity, 2 units of time. All right, and this one had twice the velocity, so therefore it all worked out just fine. 2 units of time for 2 units of velocity. All right, so back to what he did. So he took numerous springs, okay, all right, numerous springs, okay, and then he's compressing them, and then he releases, he makes a release system, okay. His first release system was to use his hands, all right, and he's just going to launch a 1 mass and then a 1/2 mass, okay, and he only got twice the distance from the 1/2 mass. So instead of it going 4 times further, even though we would expect it's going twice as fast. So his argument was this was only going 1.4 times as fast. So he compresses the spring the same amount, releases it, and he only gets 1.4 the velocity out of the spring. So the spring doesn't conserve the momentum. Clearly, to conserve the momentum, it has to be 2. So, just as Lewin would say, if it's half the mass, it has to be twice the velocity. So Lewin's wrong. It doesn't have to be. Okay, that's not how springs work. Springs don't conserve momentum, so you don't have to worry about any of this. Now, I pointed out the obvious flaw was the higher speed does require a higher pressure in the sense that the pressure has to be released quickly. So if you don't use a quick release, okay, you're probably not going to be able to capture the higher speed because you're going to release in such a manner as you're going to destroy the almost instantaneous manner, the very quick manner that you need the energy to go into the object. The object almost immediately starts going at its full velocity. It really doesn't accelerate over a long period of time. It accelerates in a millisecond to the actual velocity. The spring gives the full velocity. It doesn't give a little bit, a little bit, a little bit, a little bit. All right, anyway. So, so that's the first claim I made, is that his releasing system sucked. So first he used his fingers, and then basically he just used a fake finger. Okay, he made a fake finger and he pulled the fake finger out. So it had the same flaw. It wasn't quicker. It was just mechanical instead of, tactile. So he just replaced his finger with a stick, let's say, but he didn't release it any quicker than you release a finger. So it wasn't very useful in terms of making the release quick. Now, obviously, the way you make quick releases is usually to have some sort of tension device that you can release it very quickly by just cutting a string or some kind of mechanism like that ensures that in one moment it's tied and in the next millisecond it's not connected anymore. You have to make it release quickly. Now, the other problem was he has springs, numerous springs, individual springs. And the problem can be is that one of the springs has more tension. It has a different K value, a constant, spring constant. And what it'll actually do is, because it has a little bit higher pressure in it, it'll launch the other springs next to it. So it'll end up pushing the springs apart. So instead of moving the object, you'll end up moving the object with these two springs attached. Or you'll move it with these three strings attached. So the springs are actually launching each other, okay, instead of the object you're launching, and therefore the springs will end up flying, okay, because they won't give the energy to the object, they'll just fly off. So I suggested the logical thing to do would be to tie the springs together so they can't launch each other, and also tie them to the base so they can't in any way fly, okay, and consume any of the energy that's supposed to be going into the objects. You're attempting to test what the springs give to the object, not what the springs give to each other. Yeah. So they're pretty critical flaws. No quick release, and no consistent, in the sense of no reliable launching mechanism, because the springs are not capable of directing the energy in one direction, and that you can have the energy going in multiple directions, which is counterproductive to the idea of getting the energy into the object. So anyways, but he says he's now proven the 1.4 theory, so that's his opinion. He did his little rickety shitty experiment, and he thinks he's proven Professor Lewin is wrong. Okay, you do not have to conserve momentum. Now, he won't make a video, because he's a coward, saying Professor Lewin's wrong. He won't title the video Professor Lewin is misinformed. Professor Lewin is talking garbage. He won't make any indication of concession that he is disagreeing with conventional physics, that their theory is wrong, that momentum does not have to be conserved, and he's proven it, okay, with this garbage experiment. And again, this is in the context where these assholes keep saying people should make more garbage experiments. Garbage experiments are great. Amateur experiments are fantastic. No, they suck. Okay. These experiments should have been already done. So everybody should be able to agree on that, right? Nobody should disagree with the statement, all these experiments should have been precisely and well documented by physics. And they won't even say that. So even though these are really inexpensive experiments to do, any university without spending a little bit of time could do them in a very clinical, just decisive, well videoed, well constructed, precise, precision all over the place, and it would cost, what, $50? I mean, it would, the expense would be, even if we devoted $1 million to it, okay, and a year to do just these kinetic experiments, it'd be money well spent. Just gigantic in terms of establishing the truth of what they're claiming, but they don't do it. Just like they don't redo the Eddington experiment, just like we don't see, okay, We don't see most of the experiments they do. We just hear what they've concluded the results say. You don't get to see the gluon or the puon or any of these crappy things, because the actual data isn't as they describe it, and that's the simple truth. They misdescribe the actual experiment. They can't describe, for example, the two-slit experiment accurately to save their lives. All right, so we put this back up and continue with this slop.
Showed that quite successfully, actually.
So he says he showed it quite successfully. So he showed springs don't conserve momentum. So it's a giant accusation, in my opinion. It does go against everything the teachers teach, that springs do conserve momentum, that twice the weight, twice the expansion, that there's huge correlation between momentum, weight, and the function of springs. But he claims he's proven otherwise, but he won't claim it. He won't take credit for his new discovery and the fact that he's debunked conventional theory. Instead plays this game that he's just attacking me, who's in the position of defending conventional theory, right? I'm defending conservation of momentum. He's attacking it. Well, conservation of momentum is conventional physics.
Now here's a little suggestion for you, Gary.
So this is just, so instead of doing something, okay, so instead of explaining why in 350 years his science hasn't produced a single piece of evidence demonstrating it takes 4 times the fuel to go twice as fast. That's their claim. And in 350 years, nothing. 0. 300 years, 0 physical evidence that that's a truth. 0. Not a single fucking experiment that I can show you demonstrating that to be true. Nothing. Even indicating it. And yet he's telling me what I need to do? You have a theory for which you have no evidence, and you're telling me I need to produce evidence. Sorry, that's laughable. Your side has had all the money, all the scientists, all the universities, all the laboratories, all the air tracks, all the everything, and you haven't produced your evidence. Anything that could be called credible evidence. I mean, you have nothing. You have clay experiments from the 1700s, which I've already debunked. And what else do you have? Oh, the rolling thing. Yeah, and I just debunked that in this video. The rolling thing, sorry, not even close to a good theory. That friction is the same no matter how fast you're going. Too silly almost. And you almost argued against it right here, pointing out that, well, certainly if you change the mass, you're going to change how much friction there is.
Of a simple test you can do yourself with your scales.
So more nonsense. I should actually use this scale and do, fancy experiments proving physical reality. Why? Why should it be done with this particular piece of shit scale? Which is just a spring, by the way. I mean, it's, yes, it's not that sophisticated.
You like dropping weights on scales, don't you?
No, I like demonstrating physical principles, and the simple physical principle is that whether the scale is this way or the scale is this way, it's just measuring impact. So let's test his theory. So let's say I have me, and I am running, and I run into a big scale. So a scale this big, okay? And like a football player, I run into it, bang, okay? And it reads a certain amount of pressure. And let's say I clone myself, right? And so there's a second me, and we both run together at the same time into the scale. What do you think it's going to read? I mean, realistically, the same speed, just 2 of us now. So it's just 2. He says, okay, what physics would say, no, that wouldn't be the answer they would guess, right? I mean, everybody's going to guess. I think all the physicists are going to say, well, all you've done is add another person. You're just doubling the pressure. You're doubling the momentum. There's just going to be twice the reading on the scale. There's no other answer that's possible. I mean, there's no other. How could this be 4 times the energy? I mean, because I added another person, I've now created 4 times the energy. So, I mean, I think everybody knows the scale is going to go twice as far. I mean, and by their theory, you know, what's the how can you explain your way out of the simple mechanics that there's just a clear relationship between one unit of weight and another unit of weight, and it's 2 units of weight, and it compresses the spring twice as much, and it's not 4 times the energy. 2 of me running at somebody is not 4 times the energy. It can only be twice the energy. It can't be 4 times the energy. It's not going to move the scale 4 times as much. It's too silly. Well, he's saying moving the scale twice as much is 4 times the energy. So his argument is that the 2 me's run into the scale, and the scale only goes, 1.4. It only goes 0.4 further. So the second guy only adds 0.4. So that's his theory. 0.4, not 0.6, not 0.7, 0.4. So, I mean, obviously 2 people running into the door won't help push the door down at all. I mean, it's such a feeble amount of extra energy. Bullshit, I say. Right. Continuing.
And I thought of this that you could do is.
So, yeah, I've already done, this experiment enough to my satisfaction where I went out and I said, well, how much does something weigh? And so I drop it on the scale from a set distance. And then I dropped it from 4 times higher. And how much does it weigh? And it weighs exactly as you would expect, twice as much. 4 times the distance, twice the weight, because it's twice the velocity. Twice the velocity compresses the scale twice as much, not 1.4. So, yeah, I already did these experiments to my satisfaction. I mean, I'm quite convinced. You lift an object you lift an object 8 to 10 millimeters high, and you'll double its weight. Because I found that curious, right? What's the height you have to go to double your weight? Because technically that's 4 times it's 4 times the height that gravity does all the time. When something's just sitting on a surface. So technically I'm doubling the weight. That means I've now produced 4 times the height, which would be twice the velocity, of the velocity I have when I'm getting crashed into the earth. And so it's 1 centimeter. So it's as if you were moving 1 millimeter in gravity is sort of the same as not moving any. Okay, so those 2 numbers have to be somewhere, It just has to do with the fact that obviously in nature it can do things every trillisecond or, gillisecond or whatever. And we can only really calculate things in the, we can only see in the, half second, quarter second kind of way.
It would be an interesting experiment. If you drop the one mass, one height, which is 1 velocity, say.
So I don't know why he can't do this experiment, but whatever. Why their physics can't do it. So, like I said, they've had 350 years to shore up their theory, and they've produced 0 physical experimental evidence. So, he just talks about all these. Why haven't your physicists done it? Why haven't physicists done any of these experiments? They haven't dropped things on the scales. It seems a pretty important way to measure how much energy something has, to see what it weighs. Weighing is sort of important. You haven't weighed anything? Moving?
So we're looking at what you say is the energy is recorded on the scale, mass times velocity.
Yes, it's an instantaneous reading, so you're only going to see it as a maximum reading. So you just watch the little needle, see what the maximum reading is. It'll only be there for a tiny portion of time, and then it'll go right back. So, obviously, yes, it's just a maximum reading will tell you what the total maximum compression of the spring was.
You get a result on this scale. Now, what about if you then drop half a mass? Get something that weighs exactly half of this one and drop it at twice the velocity. You know how to do that. 4 times.
Well, yeah, why would I bother? I mean, we're already conceding the point, so I'm conceding it. I mean, I'm saying quite clearly that if I drop something from 4 times the height, I'm going to double the velocity and I will double the weight. So there's absolutely no mystery to this experiment at all. And if it's half the mass, and a momentum compresses spring. So again, until you show me some experiment demonstrating that momentum doesn't compress a spring, which you can't do, and which I think I've already demonstrated that obviously if I put one battery on a scale, right, and then I put another battery on this, I'm only doing 2 units of work. I'm not doing 4 units of work. It will compress the scale, okay, twice as much. You know, Hooke's law. So you're the one arguing against those basic things, those basic truths. And you're just playing this little, whatever this is, this little smarmy, trolly bullshit. That somehow I'm the one who obligated to produce an experiment and your physics doesn't have to produce any credible experiments. And I say bullshit to that. Then I could just go back to the Mythbusters. You haven't debunked the Mythbusters video. Why didn't the cars crush consistent with kinetic energy? Why was it perfectly consistent with momentum being in control? Twice the speed, twice the amount of crushing, not 4 times. Then they crush clay and they get the same thing. Twice the speed, twice the amount of crushing, not 4 times.
Times the height. Drop it at twice the velocity. According to you, it should weigh exactly the same on the scale.
All right, I would argue that according to, I think, most physicists, so if you just do this diagram for most physicists, I think they're going to say that, yes, half the mass, twice the velocity, that will be the same compression as 1 mass at 1 velocity. Yes, springs conserve momentum. Most physicists, I think, do actually believe that. So I don't know, who is this video directed at? Again, you're talking as if your side is full of a bunch of confident people that springs don't conserve momentum. Well, does Piro believe springs don't conserve momentum? Do all of you people believe springs don't conserve momentum? I haven't heard you say it. I haven't heard Professor Lewin say it, that's for sure. So until I hear some of you saying it, what's the point of this? Why are you preaching your theory, your personal little theory, okay, without preaching it to the institution that disagrees with you? The physics institution disagrees with you. Why are you arguing with me? Why don't you argue with Professor Lewin, coward?
Because it has the same energy. Mass times velocity. Half times 2 is the same as 1 times 1. What do you think would happen? Kinetic energy would predict that this one...
Yes, it's twice as much. It would predict it's twice as much, even though we know it doesn't take twice as much energy to throw something half as massive twice as fast. We know it doesn't take twice the energy to do that. Everybody who's ever thrown anything knows there's no way it takes twice the energy to throw something twice as light, twice as fast. No way! So we know that can't be true just from everyday personal experience. There's no way it takes twice the energy to push, 60 pounds versus 30 pounds, and it takes twice the energy to make the 30 pounds go twice the speed. I mean, come on. No, it doesn't.
It's going to weigh more because of the extra energy, the kinetic energy.
Yeah, it's not going to happen. So again, why don't you do the experiment? You seem unconvinced that what the answer is going to be. I'm quite confident what the answer is going to be. So you do the experiment. Let's just say he already has, and he's probably done it in some stupid moronic way again. But I don't know. Obviously, my scale indicates every reason to believe there's no way you could really fuck this up, frankly. Springs measure momentum.
You say they should weigh exactly the same. I think you should do this. You like dropping things on scales. Try it.
No. Let's understand that momentum is the MV part, right? So we know for kinetic energy and momentum, you have to conserve the MV, don't you? Come on, just think about it. Come on, you can't mess with that. But anyway. Piece of shit video. Anyway, let's go see what we got in terms of, well, you might as well play the last millisecond. So, you know, I've already pointed out there's absolutely no point in me doing rickety experiments in my basement. I mean, if that's what physics has to resort to, it has to be saved by somebody doing rickety experiments in their basement. Clearly, the point is that your physics proves nothing, okay? They're willing to prove nothing. You're not willing to do any of the experiments, could produce any of the evidence. You just want to talk your Jesus theory. You don't want to show us the videotape. So you're just like a Sasquatch people. You know, I don't need fucking evidence. I saw Sasquatch. I don't need no fucking pictures. Okay, or the UFO nuts. I traveled to Alpha Centauri and I went there and they told me all this stuff and they gave me the special knowledge. You're just storytellers. You don't give a fuck about a fact or physics or science. So fuck you. You prove it, fucker. Yeah. With a credible experiment. Doesn't have filth and crud all over it. Alright, let's see what he says. Note, in Steve's test, the half-mass skidded and did not rotate, so all the energy was linear kinetic energy, allowing it to go faster. So this still doesn't make any sense. It went at the appropriate speed, and you really should be saying that the other object lost some of its linear velocity to rotational energy. And then you still have to indicate how that rotational energy is a substantial portion of the energy, which it obviously wasn't. Then it would have, if it had rolled, blah, blah. So, oh, we don't have any other comments. We just have the troll. So I don't see your comment, Merker guy. So, too bad. He just likes to wave it around in his videos. Whatever that means. I'm not sure he even understands what it is when he holds it. You people really got some weird ways of describing things. But yes, at least I have something to wave around. Anyway. Given that he can't even distinguish between weight, energy, and momentum, well, how exactly should I distinguish between them? I mean, what's the big giveaway? I guess you don't have the experiment, so what am I supposed to, where's the big giveaway that just proves that weight isn't momentum? A mass moving a velocity pushes a spring. A mass moving a velocity hits a lever. A mass moving a velocity is how everything interacts. Bowling balls are masses with velocity. They exchange with the pins. The pins take the mass and velocity away. They take the units of velocity away. How is that not how it works? So he diagrams, Mindless Marvels isn't going to diagram for you, show you how the 8-pound bowling ball dispenses the kinetic energy. That is, it gives the universe more pin knocking down power. He's going to be stuck with knocking down exactly the same number of pins going exactly the same speeds because he can't change those relationships. He can't change how the units of energy are dispensed. I just got my third band from Gary in 3 days. So you just keep making sock accounts is what you're saying. Okay. I'm going to have to make more Google accounts if he bans me another 23 times. Sad face. And again, so you think anytime somebody gets banned or blocked or told to fuck off, that it somehow isn't for good reason. So you made a lot of just lazy, weak accusations that I'm supposed to defend myself against. you say, I don't believe in units. I don't understand units. When I've made thousands of videos, they all have units in them. I talk about the units, and most recently I have almost exclusively kept pointing at 9.8 meters per second and emphasizing the unit it is in. That it is not feet. It is not pounds. It is not light years. It is not some other unit. It is in the unit of time. And you couldn't understand that simple point. That I don't care whether you want to square it. I don't care if you want to cube it. The point is, it's in units of time. And you'd have to be a complete imbecile, someone who hates NASA, okay, to believe that NASA doesn't understand that it's units. A number of units of gravity happen in a unit of time. Okay, that it's an amount of gravity. They know that it's 9.8 and in the first second, and then the second you're going 19.6, and then the third second you're going 40 whatever. They know that, and apparently you don't. Okay. Today he said weight is momentum. Well, I've been saying that for a very long time. Yeah, of course it is. I can create it going this way, okay? I can create a weight on the scale running this way. And I can make the scale show a weight that I could run at exactly the speed that would make me weigh, okay, my actual physical weight in gravity. So I could duplicate the force gravity creates by actually just pushing into a scale. Yes, scales measure energy. That I've said that too. He actually said scales measure energy. Yeah, that's right. This is an energy detector. That's my accusation. And I'm sure you'll never provide any coherent argument explaining how this isn't an energy detector. All right, currently my weight is 1,000 newtons on my planet, but my momentum is 0. So you think your momentum is 0. I'm just saying you're obviously putting pressure on the Earth constantly. So you have a velocity. You can't constantly apply a pressure if you don't have a velocity, can you? So, okay, because you can't see the velocity, it means it doesn't exist. That's all you're saying. You're so dumb that you can't understand any concept you can't see physically with your eyes. So if you can't see an electron, you can't believe in an electron. Is that your argument, fuckhead? How does that work? So if I explained it about 7 million times, it's clear that you are, okay, pushing in to the Earth more than the Earth pushes back because you do it first. You push in first. It pushes you back. You're always going to be ahead. See, when you've pushed twice, it's only pushed back once, right? So you're always one ahead. You're always 0 or 1 ahead. So what's the average between 0 and 1? Well, the average between 0 and 1 would be 1/2. So you're always 1/2 ahead. You can't understand that? The average would be 1/2 the amount of energy. Half the time you're pushing in more, 1/2 more, than the Earth pushes you back. So you do have a velocity. You just can't see it because it's doing this. And the Earth just keeps putting you back where you were, you dumb idiot. Okay. I'm sorry you can't understand that. But see, you can comment here. You can make your little ragged comments. And you can talk your little shit. Okay, no problem. You could have typed a comment in my comment section, but I'm not, like I said, I have no obligation to personally tutor you, okay? And things I've said hundreds and thousands of times in videos. I really don't have an obligation to constantly put up with this personally tutor me thing. If you don't want to watch the videos, you don't want to really understand what I said, then you can't lie about what I've said, okay? And I clearly don't disrespect units in any way. Saying per second is baby talk. That's my accusation. That you have to be you have to have very little inhibition, okay, about saying something very imprecise to allow yourself to use that kind of language. And it's like, could be like saying spontaneous. That's really a dangerous word because it really isn't any such thing. There's cause and effect. There's not spontaneous. Saying random, because if you really know about it, all it is random-like or randomized. But it really can't be truly random. Okay, so you just don't understand the concepts and the vocabulary. And yet you talk like an arrogant, obnoxious shit. And you can't make a video, so you're useless. So yeah, let's see what it's on his channel. Oh, it's a troll. It's a sock account. Yeah, he has more than one channel. Oh, look at that. It's a shot baby deer or something. Got a little bullet hole in his brain here or something. I don't know what this is. Oh, fuck. Whatever that was. Okay. That's how he represents himself. Alright. So somebody with 3 names. Does Ian think springs are exponentially harder to compress? Of course he does, yes. Or how can he misunderstand? Well, he actually thinks that's how it works, right? It's actually takes more and more pressure to push a spring, right? Your first little bit, oh, that's easy. Oh, it's harder. Oh, it's harder. So he's basically saying the second half of the compression has to be harder than the first half. And in theory, that's sort of correct because the energy has to come at the same time, right? If I run into a scale and then I walk away and I have my clone run into the scale after me, well, yeah, I'm not going to be adding the energy at the same time. So if I don't add it at the same time, I'm not going to get the same effect. I'm obviously not going to get twice the compression of the spring. Alright, depends on the gram weight of the spring. What about 2-stage springs? So I don't know exactly what to make out of that one. I don't know what a 2-stage spring is. So, yeah, can't do anything with that. The spring rate, I don't think it really matters what the spring constant is, besides the fact that the spring has to be able to expand. Its expansion speed, without a weight on it, has to be substantial enough to be able to create the speed, the higher velocity in the object. So it has to have a expansion speed that's whatever the required multiple is of the speed you wish to create with the spring. So, that's where the spring constant becomes relevant. But I don't know if it's that rigid, look, I've already played videos where people basically say, look, there's only 70% of the spring that's usable, right? I mean, you can't over compress it, and the first little bit of compression is a little bit weak too. But you also can't have extra coil, you can't have ends on the spring, coils that are on top of each other that aren't spring, and count that as your measurement. That can't be part of your measurement. Your measurement has basically the coil distance is what you should be measuring. To be actually precise, you should be measuring the distance between the coils. Alright, the spring rate in 2-stage springs would change during compression. Doesn't necessarily mean it's exponential. Would just depend on its design. So like I said, I really don't know what a 2-stage spring is. He used valve springs, from a car, I think. So they're really stiff springs. He was using, 1 pound, kind of 2 pound weights. So they're really stiff springs. But obviously they're probably used valve springs. So their constants are probably not consistent anymore. Let's see. The spring rate in 2-stage springs would change during compression. Yeah, I just don't know what that means. Anyway, good question. Not exponential, most likely. I have 86 gram spring. I'll test. Okay, well, fine. That's okay. I mean, more amateur experiments is, it's all we have. But I'd still like everybody to agree that these experiments should be done correctly, precisely, without any, wide openings for shenanigans and gimmicks and bullshit. I mean, some of them are very simple. I mean, the one that Toady was going to do with the, a twice-ive massive ball, hard steel, and another half-mass steel ball, and just make a simple Newton's cradle out of those two things, I think would have been insightful. I think the thing is all these experiments will get different answers depending on what materials you make them out of. And then the other thing I was thinking is that all these experiments, once you have a precise experiment, moving a one mass into a two mass, would be to do the simple thing of Michelson-Morley, rotate it, and see if you get a different answer. See if you get a different answer when it's the two masses going this way into the object and the two masses going the opposite way. Rotate the experiment, see if it changes any. Do it with enough precision that you could detect those changes. And I'm wondering, just because these experiments do seem to come out differently each time you do them. So, I mean, I'll just illustrate real quickly what you end up seeing. At least I found in my experiments, and I've seen it in other people's videos. So, where the hell is my drawing device? Did you see where I put my drawing device? Yes, I seem to have misplaced it. It couldn't be under there because I didn't lift this up. Floor. Didn't stick it behind my ear because it's really big. Oh, I stuck it over there for some reason. Anyway. It's tough getting old. All this stuff that just disappears. Just remembered a cat's name I couldn't remember before. Maui Face. I'm saying, how could I forget that? I mean, I fed the cat for 7 years, 8 years. You think I'd know its name. You remember its name. Anyway. But, it's life. Alright, so you bang something in. Alright, and you bang it into like the two mass here or whatever. One mass, and you got a spring. And then you're supposed to get this reflection. So it's like the Newton's cradle. So when you actually do something like a Newton's cradle, I mean, I guess I've done something like it with the ballistic pendulum. And the fact is this recoil, okay? I mean, the lighter object, you're dropping it with a velocity, and you get this recoil. Well, sometimes you don't get much, right? Sometimes it seems like all the energy actually does go into the object, like when it's a 1/2 mass, okay? So it's pretty... It's not like it's a 1/8 mass where you can't ever do that. You're never going to drop the 1/8 at the higher velocity and get this thing to fly off it with all the momentum. But it just seems very variable. I mean, how much you get back doesn't seem at all to be like it's the same 33 it's supposed to be, or whatever the number is supposed to be. It doesn't seem to show any consistency. And that is curious. I mean, it makes me wonder whether this could be part of a relativity argument, that you could actually debunk relativity theory with something as simple as a Newton's, a modified Newton's cradle. That would be funny. If you could actually show that it is dependent on which way it's orientated, which would be consistent with which way the planet's spinning, that it would be ironic if it turns out that's true, that such a simple experiment could show that correlation. But we'll see. It's only an observation at this stage. It's not I'm not making some grand assertion about the truth. I guess we can... Oh, that's not the one I want to move. I want to move this thing. Yeah, so we're done with the comments. So, good question. Okay, so there's a video you might want to look at called the Spring Paradox. I already played it in my video. So that's the guy, whatever he's called, some kind of weird name. Brock or Blokey or Parth, right? Parth. I think that's his name. Parth. Right? So that's the video, right? I actually played it in my video, okay? And I did it like 3 weeks ago. And, see, you people really just, don't want to pay too much attention to what's going on here. But it's okay. Whatever. Yeah, so he just pointed out there's two ways to do the equation. You can do it the momentum way without the squares, or you can do it the kinetic energy with the squares, and you get two completely different answers, and that doesn't make any sense, does it? No, it doesn't. And then he made the kinetic energy one. He tried to rationalize the squared kinetic energy one by talking about relativity, which was sort of ironic, that he's trying to use relativity as a way of getting out of the paradox. I mean, mathematics isn't going to save this. I mean, really, these experiments have to be done. Like the Eddington experiment, you can't keep saying something's true unless you do this simple experiment that proves it. So if you're unwilling to do the simple experiment that proves it, show me it taking 4 times as much gas to go 60 miles an hour as it does to go 30. Till you do that simple experiment, fuck you. I mean, this is all just bullshit. Can you dismantle the ball on the street experiment showing space-time? Huh? Ball on the street experiment. There's a ball on the street experiment? I guess I never heard of the ball on the street experiment that shows space-time. Yeah, I don't think so. That sounds kind of silly. So let's go find this ball on the street experiment. Okay, so far so bad. What is science? No, that's not it. Gravity visualized. It now has 135 million views. And it's a shitty example of gravity, right? I mean, he has spandex, a big pool, a pool, a little kid's pool with spandex put over it, and then puts a weight in it and does the fake well thing. And it's just so bad because it really doesn't make you understand what gravity really does. Because every time he drops something from the outside and it doesn't hit anything, it should fly right the fuck back out of the pool. That's what gravity would really do. Ugh. Ball rolling down curved or straight ramp. Okay, well, that won't tell us much. So let me look at the experiment. Oh, there, I can see it. All right, so he's dropping it. He curves means it's just doing the free-falling thing. So it's not really that informative. That obviously it will gain a higher velocity if you reduce the amount of bending, okay? So the more relaxed you go with a straight line, but the more bend you put in the line, the faster it'll be because it's actually free falling more of the distance. All right. Wandering static balls. Well, that static electricity. It's sort of interesting. It's funny that I actually got a couple of interesting videos here. Can you see? Yeah, get this out of the way. Some of these are almost interesting. Yeah. All right, so here's the so you can see it there. So that's what I was talking about. So the one in the middle is the fastest, okay, because you're minimizing the amount of turning friction and you're maximizing the amount of free falling. So you're really trying to find the perfect balance between how much friction and how much opposition to its motion you're providing, and how much free falling it's doing. All right, so this one, there's the static balls. So they're static in the sense that they're charged, and the surface is obviously likewise charged. Okay, so that wasn't bad. Oh, that's a Bruce Yearney video. That's a long time ago, 2 years ago. I didn't see that one. So anyways, plastic sheet of some kind. Okay, plexiglass, and then he charges the plexiglass, and then he charges some styrofoam balls, I guess. And finds that the balls are, I don't know what these are. So he puts them underneath. Okay, and so they're statically connected somehow. Alright. Well, maybe we'll watch this. What the hell? Ads. Fuck.
So what's causing them to move? When I rub the lid, I'm actually creating it.
So the charge on the glass or plastic won't be even. That's the nature of insulators. So some places will be charged, some places no charge. So it'll be very kind of randomized where the charges are on the surface, because you can't conduct the charge out of the surface. The surface won't conduct it, so he can't just put his finger one place and pull all the charge out of the entire surface. He's stuck with it being caught in different locations. So unless he pours water over it or some other mechanism to pull the charge off, he's sort of stuck with charge being all over the place in different places.
Static charge. When I look at the triboelectric series, I see that my hand or furs actually become positively charged by giving up electrons. The lid, on the other hand, becomes negatively charged by gaining electrons. We know that like charges repel each other. Positive charges repel positive charges, negative charges repel negative charges, and opposite charges attract.
So we still don't know what the little beads are.
Initially, the plastic sheet and the balls inside are neutral. But as I rub my arm on that plastic, a negative charge.
So it might also have something to do with the hairs on your arm, but whatever.
Builds up on the lid. The balls then change positions, with the negative charges trying to stay away from the plastic while the positive charge on the ball is attracted to the plastic. When I bring my hand near the surface, it disturbs the charge, causing the balls to move.
And again, I'd still say that the real important point is that the charge isn't even on the surface. It's in clumps. Okay, so there's clumps of places on the surface where there's a lot of charge, and other places where there's less charge. So it's really uneven charged. And that's the real point.
Now let's try this once more. This time I want to put a couple of the balls on top of the sheet and see what happens.
He doesn't say anywhere in the video what these balls are. When foam balls are placed near plastic sheet, so they're foam. So
now let me charge up the sheet. I'll drop the ball on it.
And it has to be low humidity. Yeah, that's why these never work. As a basement dweller, it's hard to get anything chargy to work.
There we go. Now watch what happens. The ball just dances around the surface whenever I get near it.
So the interesting thing is the speed. I mean, this would be great for a slow motion camera to see, especially when it does the loop-to-loop. Like he puts a little bit of energy in, and it goes a whole convoluted path. That's really interesting. And because you could just basically diagram what it's running into. And like cloud chamber experiments, you could argue that it's sort of, there's going to be mysterious motions where it's going to move and there's nothing in the way, nothing visible in the way.
Now let's try a simpler version. I made a box out of aluminum foil. Get it straightened out here. Okay.
I guess that was a bought version. Again, this video I played from the beginning. He doesn't tell you what any of this stuff is, so not that I saw. Let's try it from back here.
Today in Homemade Science, we're going to look at an update of the mysterious wandering balls.
Yeah, somehow I missed the intro. Really pissed on ice.
Now this experiment starts with this plastic sheet. In this case it's polycarbonate, but other types of plastic will work. And I've made a nice box for it to sit on top of. Now we can do this easier if we use cardboard or as we'll see, aluminum foil. But the heart of this demonstration are these pith balls. They were purchased from a science supply company and they're very cheap. And we'll put them in the box here and put the plastic on top. And look what happens. They start bouncing around. And if I rub my hand over the box, we'll see these balls bounce around inside the box.
So he said polycarbonate, so I don't know whether acrylic would work, but whatever. Interesting.
So what's causing them to move? When I rub the lid, I'm actually creating a static charge. When I look at the triboelectric series, I see that
Okay, we saw that part. Okay, so we'll go back up to here. Some place where he's making the cheap version.
Now, quite often I get asked, what if you can't find the styrofoam balls or the graphite paint? Is there some alternative we can use? And their answer is...
Okay.
And I'm going to rub it with my wrist. I'm going to use these 4 blocks to hold the plastic up. Put these in the corners. There we go. Let's put the balls inside. And put the plastic sheet on top. And I'm going to rub it with my wrist. And once again we see the same type of behavior.
Now, quite often I get asked, what if you can't find the styrofoam balls or the graphite paint? Is there some alternative we can use? And their answer is yes, there is.
Here's some very small styrofoam balls that were removed from a stuffed toy. You do want to keep this between the 2 sheets of plastic. If it gets outside of it, it gets really hard to pick up. Larger foam balls are readily available, and instead of painting them with a graphite paint, I'm going to wrap them in aluminum foil. You want aluminum foil that's as thin as possible. Tear off any excess. There we go. And simply roll it between your hands to make it tight. Now let's go give this a try. Here's another simple setup. The plastic's on top of 2 wood slats. I'm going to rub it with my arm to give it a charge. That should be good. Let's try it.
So
These things
wow,
work pretty good.
you can see there's. I mean, the good thing to see about it is the fact that the velocities are changing, and that somewhere it's as if, okay, he puts a little bit of pressure in on one direction, and obviously more than one charge is pushing back and creating a higher velocity. Because he doesn't poke it with enough energy to theoretically move the one ball fast enough to knock it off the table. But it flew off the table. Now, size, you see that again.
Now, we started with the smallest ones, but we have 2-inch, we have 2.5-inch, we have 3-inch, and we even have a 4-inch. Now we're going to switch over to a larger piece of plastic. This is 18 by 24, and it's also a 1/4 inch, so it's going to make it a little bit more sturdy.
As my hand gets near or touches the ball, there's actually a small spark between the two. It doesn't hurt at all, and if you listen closely, you can actually hear it.
Pretty cool.
To keep the balls from rolling off, I made bumpers out of masking tape. I used wide tape and I folded the edges down to keep the balls from sticking to it.
So it's obviously taking energy off the table from different locations and using that. It's creating momentum out of those repulsive charges. And so that's sort of, interesting. And then it's also creating enough energy to create sparks. Definitely an interesting experiment. Me likey. Yes, if I lived in Arizona, I might go to the trouble. He ought to use a stick instead of his hands, just a little pointer, a little tiny charged point, and just see how much you can affect it with that little point. But anyway, too bad he didn't talk any theory, but yeah, interesting. Clearly doesn't like to go over the piece of wood, so the wood's pulling enough charge out to, are creating enough more and negative charge, I suppose. But anyway, interesting. I like that. So that was worth it. So even though we didn't find the video I'm supposed to be finding, that was interesting. So how does the ruler trick work? Why doesn't it fall? Yes, okay. So why doesn't it fall? So it's pulling the weight of the atmosphere is the argument, blah, blah, blah. So that's another Bruce Unit. No, that's the Action Lab. Oh, who cares? That guy's so full of shit. 2-minute experiment, ball bounce. Well, I don't think we'll bother with that. So none of these look like what the other guy was describing. Here's the static electricity thing again. Another Bruce Unit one doing the same thing. Weird. Another stick, another Mythbusters, same. So they're just redundantly showing the same shit over and over again, which is really annoying. But it's YouTube. Alright, dropping bowling balls and feathers in the biggest vacuum, which is all. We already know the answer to that question. Super glue idea that not many people know about. So you can put super glue on a cigarette. Well, I don't know why I would do that. Styrofoam, PVC pipe, amazing. A few people know the secret styrofoam and PVC pipe, amazing idea. Okay, well, I'm curious. You just shove styrofoam into the crack and it seals it. You must have to use glue of some kind. Yeah, we can just watch the video. Yeah, in its small form. Okay, yeah, got it. Okay, I cut it to the right size, and then I apply, I guess it's super glue. Okay. To both sides, and it will melt the styrofoam, presumably. Yes, it is melting it. Okay. and then you put the melted goo into the crack. I think this would work with baking soda also. So you could just put super glue on baking soda, and it will also create a epoxy-like substance. Question is, how long will it last? But who cares, right? As long as it stops the problem. And, yeah, we might be dead in another day, so who cares? It doesn't last. Whatever. Obviously, I guess I would coat it with some sort of rubber cement or something to prevent it from, in any way, being deteriorated by sunlight or whatever. Okay, I guess that's it. Oh, no, it smushes more in there. Okay. Yeah, we get the idea. Okay. Got it. Don't be pushing too much because you'll just push it right through the hole. There you go. It's fixed. Okay. Oh, I like that. All right. So back to the whatever commenter thing. Where the hell did it go? I'll put it down here. See if there's anybody saying nothing. Value. Sheet experiment. Well, I copied and pasted and it didn't work, so fuck you. So whatever. Hello, Gary. If a 15 kilogram object is subjected to a force of 175 newtons, whatever, to the east, and another force of, okay, so this is, I'm not going to do these thought problems, these word problems, it's just no point. To the west, what is the object's acceleration? A 15 kilogram object subject to a force of 175 newtons to the west, and the other force, whatever the other force is, of 1,020 newtons to the west. Both forces are being applied. Let's say to the east. Right or left, you could just say. What is the object's acceleration? I don't think you have enough objects in here. So you have 175 newtons going east, and you have 1,020 newtons to the west. So they're just weights. You just subtract them. Can perpetual motion exist? Is it possible? Well, you're just wasting everyone's time. I mean, you really are this stupid? It could possibly exist in space, okay? Outside of all influences, you could create a battery, for example, that holds its charge forever. Or you could put energy in, and you could watch the energy go forever and ever and ever and ever and ever, theoretically. So if you make a perfect container, you can put energy in, and you can just watch it do this forever and ever and ever. So yes, perpetual motion is possible in perfect environments where you don't extract any of the energy through scattering heat, through dirt or noise. That's why superconductors work. It's because they're basically taking the dirt out of the system, the noise making bits. But they don't make energy. They just hold whatever energy you put into them. So yeah, theoretically it's possible, but it's not meaningful, but you can't do it in some kind of, you're not going to do it on Earth. So the balls are displaying multi-charge displacement. I don't know. I guess that's what you could call it. They're displaying the fact that the charges between the balls and the plastic are constantly changing. Depending on where the balls go, they change the charge in the plastic. And so then they have to keep moving around. How much energy is the plastic sheet? Is in the plastic sheet? I don't know. I didn't measure the coulombs. So you have to figure out how much energy went in, I guess. How much rubbing you did is going to equal a certain amount of charge that you're displaced. Let's see. Super glue with graphite. Some from a pencil is very strong. Yeah, well, I've seen it. I've done it. Okay, so I've used the baking soda trick. and it makes rocks. Okay, so it's that simple. Okay, so you put if you can get the baking soda to fill like a little gap or a little seam or a little crack or some other kind of thing, and you just push the baking soda, a blob of it. The baking soda goes inside the crack. Obviously, it's very fine, and as soon as you put the glue on it, it turns to rock, and so it basically solidifies it in the gap, and it works quite well. But super glue is a pain in the ass. So that's the problem. You can't put it in a bottle and be able to use it more than once. I mean, it's just this. It's so difficult to be able to store super glue in a way that isn't, obnoxious. So, but I haven't had tested how long it lasts. But there was some guy who was actually fixing like vintage guitars and stuff with the baking soda trick, and he'd file it like it was wood and do all that. It really did work. So it's a mechanically decent fix. I mean, it's not like it falls apart in a week. Alright, well, seems you people are running out of the steam, as they say. So I guess I can call it a video. And such. So I don't know how much of it was on the subject, and whatever. Just, yeah, just yuck. So we'll see if we can get the real physicist to play along, and then he can explain to us why there's no physical evidence for any of this crap they assert. So he can explain, why don't you have physical experiments? Why haven't they done any of these physical experiments? Alright. So, till the next time, and such and so forth, and whatnot. This has been draftphysics.com. debatephysics.com also. Video presentation. Man.